In the following Network Instruments presentation, we'll be discussing the forensics capabilities which are found in the GigaStor appliance. The concept behind network forensics is quite simple. It's the ability for a network administrator to look back in time and do an in-depth analysis on specific conversations or network conditions that are of concern. Until recently, the ability for a network administrator to do an in-depth analysis had always been limited solely to statistics. And while statistics could provide a great overview of what had occurred, the level of depth required to do an in-depth analysis had always been lacking. That's where products like the GigaStor came into play. The GigaStor has the ability to record every packet in its entirety to a sizable disk array. It can record these packets in better than gigabit line rate. Now, as you can see, a graph along the top is illustrating network totals. Currently, my network totals are reflecting bytes, but I could change that by modifying the data type from the drop-down field and instead having the display provide me information on packets, utilization percentages, errors, multicasts, broadcasts, and the like. Now, as for the time frame that the graph is representing, it all depends on when I've had the GigaStor appliance running on the network. As you can see, the data range on my GigaStor spans from December 15th of 2005 through September 27th of 2006. That's illustrated in the upper left corner of the GigaStor display. In the middle top of the display is the data that's illustrated on my screen, which currently is December 15th of 2005 from 16:03 and 30 seconds through 16:08 and 30 seconds. So my screen is currently displaying a 5-minute time interval. I can change the screen resolution to provide a much narrower graph down to a 2-minute screen, or a much broader graph all the way through an 8-week screen. I've also got tabs along the middle of the display, which, as we'll see later, allow us to identify different patterns or stations of interest that had occurred during particular time intervals. I'll click first on the Update Statistics button, which you can see is blinking red. When I click on the Update Statistics button, the tabs along the bottom are populated with information. Now, this information is derived from the analysis time selection that an administrator has isolated using the slider bars along the graph in the top of the GigaStor analysis display window. I can expand this time window, or I can narrow this time window simply by moving the slider bars. Currently, you can see that my time window is reflecting information from the analysis interval from 16:04 and 30 seconds through 16:06 and 45 seconds, which equates to a 2-minute and 15-second time interval. You can identify the total number of packets that were witnessed during that time frame, the total number of bytes, and the average utilization during that 2-minute and 15-second window. Also, totals are given for the number of Layer 2 devices witnessed, Layer 3 addresses witnessed, Layer 3 conversation pairs witnessed, TCP and UDP logical addressing that was witnessed, active VLANs, and physical analysis ports on the GigaStor that capture data during that time interval. Now, as we move along the tabs from left to right, you'll see that MAC Stations provides all the Layer 2 devices that were active and their network totals based on the time period that's been selected by the administrator along the top graph. So, for a particular Cisco device, I can identify the number of packets, both ingress and egress, as well as aggregate, bytes, ingress, egress, and aggregate, and of course utilization, both ingress and egress. The number of Layer 3 stations witnessed, packet, byte, and utilization totals again. IP pairs showing the conversations which existed, and I'll expand these columns a bit so that you can see both the DNS name and the IP address of the device are listed. And of course, totals providing in each direction of the conversation, so you can determine if the conversation was between a client and a server, if the client was uploading or downloading information from the server. TCP port shows all the active logical Layer 4 TCP addresses that were used during that time period, as well as the same for UDP ports. All the different active VLANs, both 802.1q as well as ISL tag VLANs will be listed here under the VLANs tab, and of course the physical ports showing the physical analysis interfaces that are featured inside of the GigaStor that witness data during that time interval. Now up to this point, we've used the selection interval along the top graph to dictate the information that would populate the tabs along the bottom of the GigaStor interface. I'd like to reverse that now by selecting certain devices from the tab along the bottom and clicking on the Update Chart button. Now the graph along the top is representing activity levels for those stations. So whereas before I had aggregate information for packet and byte totals for the devices during the selected time interval, I now can see when they were busiest and when they were most dormant during the conversation time window. The same could be provided for TCP ports. Perhaps I'm interested to find out when SQL and NetBIOS were most heavily utilized during this time interval. By checking on those two ports and clicking the Update Chart button, I can see their activity levels graphed out. Now, of course, the goal of the GigaStor interface is to provide an administrator all the information that they would require in order to provide a more in-depth analysis of the conversation. Up to this point, we've limited ourselves just to statistics. What I'll do now is I'll click on the Analyze button along the top of the GigaStor interface. And you can see an administrator has a number of different options for how they would like to mine the data off of the GigaStor. The first option allows the administrator to mine off all the data in the analysis interval, which again is the 2-minute and 15-second window that we had originally highlighted with the selection bars along the top, applying no filtering to that time interval. The second option is to use that same time interval, but to apply a unique user-created filter that the administrator may have built at some point along the way. The final option is to allow the GigaStor to build a filter based on the items that have been checked on the tabs along the bottom and apply that filter to the analysis time range. As you can see, the analysis time range is listed here, and the administrator has the ability to modify the values down to the nanosecond. Two options exist for the analysis type to either analyze with or without expert analysis. Now, one important thing to note about the way the GigaStor analyzes its information is that while the data will be mined, it will be mined locally on the GigaStor. That means that if the GigaStor was located at a remote development facility inside of your organization, and you were connecting to it and viewing its traffic patterns across perhaps a slow WAN link, a fractional T1, or even a full T1, the data that's mined out, which could be hundreds of megabytes, even gigabytes worth of information, will not be transferred across that slow-speed connection between the development facility where the GigaStor is housed and your production facility where you as an administrator might be located. The data will remain on the GigaStor, and a thin client architecture allows the administrator to, in real time, view all the data that's being mined off of the GigaStor without actually having to move that data from one facility to the next, which is, of course, both time-consuming and also a serious detriment to the network if utilization is a concern across that T1 or fractional T1 that might connect those two facilities. By clicking on OK, Observer will build the filter, which you can see is going to contain conversations between my backup server or Richard whenever those two devices talk on either the NetBIOS or the SQL ports that we use. And when I click on OK, the trace will be mined out and will be displayed for me in the window. Now take, for instance, a scenario in which a network administrator has been tasked with mining out and identifying violations in acceptable use policies for an organization. Many times, monitoring for acceptable use policies means not only identifying the DNS entries that a device communicated with, but also providing proof that the device not only communicated with the site, but also what information was viewed while on that site. And that's where the idea of stream reconstruction comes into play. Being able to recompile the web page as the user viewed it at the time in history when they transferred the data. These are capabilities that are not available, of course, with simple statistics reporting facilities. Statistics reporting facilities would provide us with the DNS name that was viewed, or with the amount of data that was transferred. But an in-depth analysis providing exactly what was viewed, how the user displayed the information, and how it was transferred across is not available when simply looking at statistics. Forensics is required at that point, a capture of all the data and all the packets that occurred at that point in time. Inside of my mine trace, I'll come under the TCP events, and I've got a trace here which contains some HTTP traffic which I've mined off of my GigaStor. What I'll do is I'll right-click on a particular HTTP transaction and select the Stream Reconstruction option. Now when I select that Stream Reconstruction option, you can see that all the TCP header information has been stripped off. All the layer 2, layer 3, layer 4 information has been stripped from the packets. And I'm getting just the layer 5 through 7 transactions that have occurred. Here I can see a layer 7 in green GET request from my client, my layer 7 application response in red from my server, the temp file that's issued, and then if I scroll down this display, all the subsequent images, SWIFT files, all the data that was issued to the client in order to facilitate building a website. Now because we've got Stream Reconstruction within the GigaStor, and because we've captured all the data in its entirety, an administrator has the ability to click on the temp file or any of the images that are embedded inside of this display and rebuild that page as the user viewed it. Now, of course, this is Google News back when it was a beta site, back when there were riots in the Paris area, back when the Oracle CFO had resigned, back on November 3rd of 2005. And you can see, we didn't simply link out to Google News as it appears today because, of course, that's not what the user viewed. What we're displaying is the rebuilt page, completely rebuilding the HTML, embedding all the images and so forth, so that you, as an administrator, have the ability to see what the user saw. Now, this reconstruction capability is not limited just to websites and images. It expands itself into instant messaging communications, email communications, and voice-over IP communications. For both enforcement of acceptable use policies that are internal to the organization, compliances such as Sarbanes-Oxley and HIPAA, other governmentally regulated compliances, and of course just from a day-to-day troubleshooting standpoint. This has been just a brief look at some of the capabilities that are found inside of the GigaStor appliance.